Hi, let's take a look at question number 2. An object moves along the x-axis. The velocity is the function v of t equal to t times sine t, and t is greater than or equal to 0 second. At t equals to 0, the object is 10 units to the right of the origin. So let p of t be the position function. Use calculator to solve. Use correct integral. So based on the information that we know that the velocity function is the t times sine t, and this part tells us the initial location or the initial position. So we know that p of 0 equals 10. We had to use integral to solve the problems, and we also had to use a calculator. So let's take a look at part A. Find the displacement from t equal to 0 to t equals 6. So part A, displacement. We're going to use the integral from 0 to 6, v of t dt. By now I believe you remember this. So we're going to do 0 to 6, and then we got t times sine t dt. We're going to let y1 equal to x times sine x. And we're going to do integral 0 to 6 y1 dx. So let's go to our calculator. So we have x times sine x. So now we're going to map 9. Okay, so we have to type in 0 to 6. And we go to find our y1 and then dx. So now we got negative 6.0404. So we go back over here, we write negative 6.0404. So our displacement from 0 to 6 is going to be negative 6.0404. So we finished question part A. Now let's take a look at part B. Part B is to find the distance of the object traveled from t equals 0 to t equals 6. So distance travel. So we're going to do integral. We have to use the speed function. So therefore absolute value of v of t dt. Speed times time equal to distance. So we have to use the speed function. The time travel is from 0 to 6. So now we're going to get 0 to 6, absolute value of t times sine t dt. We're still going to make our y1 equal to x times sine x. So we already have it over there. But we are going to insert our integral with the absolute value. So over here, I'm going to be y1. So I'm going to show you how to insert the absolute value. So this is what we got before. So now we are going to do map 9, 0 to 6. And then we are going to have find the absolute value. So we're going to get map again. And then absolute value will be underneath the num. Okay. And then ADS, stand for absolute value. And then we put y vars. And then dx. Now we got integral 0 to 6 absolute value of y1 dx. Now we enter. Okay, so we got 12.3236. 12.3236. So we got our distance travel is 12.3236. Let's go to part C. Find the position of the object at t equals 6. So we have to use position function. So if you don't remember the formula, we still can refresh our memory. So position equal to displacement plus initial condition of position. So we have p of x equal integral and plus the initial, which is p of 0. So okay, plus p of 0. This is 0, so you begin with 0 and put x over here. The delta of p is v. So we got our equation. Now we put times 6. So we do 6 v of t dt, and plus this is 10. Integral 0 to 6 vt dt, we found it in the beginning, so we just write in the same number, negative 6.0404, and then plus 10. So now we use our calculator. Negative 6.0404 plus 10. So we got 3.9596. So we found our position at 6, which is 3.9596. Let's go to D. Find the position of the object at t equals 7. So this time I'm not going to, do what I did in part C. I'm going to write directly. I need to find p of 7. So I begin with p of 7. And the displacement from 0 to 7, v of t dt, and plus p of 0. P of 7 equal to the integral 0 to 7, v of t dt plus the initial position. So now we got 0 to 7, t times sine t dt, and plus 10. So we are going to get this part in a calculator. So we're going to go math 9, 0 to 7, and I plus 10 together. So our final answer is going to be 5.37967. 5.37967. If you want to round it, you can round it. So we finished our part D.